Lithium or will nickel metal hydride suffice battery webinar. My name is Ed McMahon. I'm the CEO here at Epic. Before we get started, just wanted to let you know that you all will be muted during the presentation. So if you have any questions as we go through, please go ahead and enter them into the questions panel located in the webinar control panel, and we'll try to get to all of them at the end of the presentation. If we don't have enough time to get through all the questions, we'll make sure that we reply back to you specifically via email. Also, we'll be recording this webinar and posting both the recording and the slides on our website and our YouTube channel for you to view in the future or to pass along to colleagues. So our presenter today is Randy Ibrahim, who's our battery technology leader here at Epic. Randy's been active in the battery and battery charger industry since the early 90s. With 30 plus years of experience in many different industries, has given him a unique advantage when reviewing and developing battery designs for many different types of industries. His work includes pioneering the development of custom safety circuits and battery chargers for different applications and chemistries. And Randy has received numerous patents in his area of work and has written numerous articles for industry trade publications. And with all of the experience that Randy has, some of the crazy designs that we are working on right now, we felt this was a good webinar. As we are seeing, some folks are actually moving back towards nickel metal hydride, so we felt that this was...
I think you're absolutely right. This is very, very timely now that with really stringent regulations that more and more folks are starting to reconsider nickel metal hydride. So hence the title of our presentation today is, do you really need lithium-ion, or will nickel metal hydride suffice? And it almost sounds like it's a secondary solution, but as you'll find as we go through this presentation, that sometimes nickel metal hydride is your only choice due to a lot of regulatory regulations that are out there. So what we're going to cover today with today's agenda is we're going to review the two different types of chemistries that go through the pros and cons of the lithium-based chemistries, and there's a whole lot of them, and also some of the pros and cons of the nickel metal hydride batteries. And for us folks in the battery world, we call this plus and minuses. Anyway, moving on here, we got the factors that we absolutely need to consider when choosing these nickel metal hydride batteries. It's the same with when you're out looking at lithium-ion. The weight is a big factor between the chemistries. The energy density, to a certain degree, is definitely a factor. Design simplicity is quite different between the two, and also time to market is a factor sometimes when choosing between these two different chemistries. And of course, regulatory, which I alluded to earlier at the introduction, and then also we can cover a little bit of cost, which is not just the cost of the product, but the cost of regulatory, and also the cost of not getting your product to market in time. So moving on, we'll, as we get through this presentation, we'll look at examples of some of the ideal applications using nickel metal hydride, where that chemistry shines over lithium-ion. And those would include some of the stationary applications, some of the very, very large batteries, and also batteries that are required to kind of be routinely transported by air due to type constraints and the nature of the product. And also, this is very, very ideal for cost-sensitive products, some of the lower-cost ones. Sometimes this is the only option. And then lastly, I'd like to cover the nickel metal hydride batteries and how they can be smart, as smart as the lithium-ion, and what that means we will definitely define and as we kind of wrap up the presentation today. So, looking at the differences between the chemistries, as you know, and a lot of people know, there's a lot of pros. That's why lithium-ion is kind of the cell of choice, and most of the time it's a good choice. But sometimes they just people pick it from a lack of knowledge and not true understanding what benefits the nickel metal hydride have. But to go over some of the pros here, first off, they're lightweight. Like cell phones you see every day, the 100% usage of lithium-ion. because they're very lightweight in nature, and you're always trying to get weight out of anything that's portable. And so you see it mostly in portable devices nowadays, and also some non-portable that require something that's very lightweight. There's also the cell has a lot of energy, a lot of gravimetric energy density. So in other words, you have a lot of energy per pound or kilogram, and that's very important sometimes in some applications. Another factor that's really important is every individual cell has a higher voltage. For the average lithium-ion battery, it's about 3.6 volts. All different chemistries within the subfamilies of the lithium family, they vary all over the place, from very low voltages to high, depending on the chemistry mixture and what ingredients they use. It does vary, but they do that because they can pull out some of the attributes that are very good in certain formulations versus others. They can highlight certain desirable features and maybe suppress some lesser desirable features like instability, what have you. But with nickel metal hydride, just to get that 3.6 volt, each one of those are like 1.2, so you'd need a minimum just to get the potential voltage of 3.6. You need 3 cells, and that there's a little bit more labor involved, some welding, what have you. So there's some trade-offs there, and it depends ultimately on the system that you're trying to run. Sometimes some systems run great at low voltage, and maybe sometimes even 3.6 is too high. So it depends on each individual application. What if this is a desirable effect, but I did put on the pro slide because the majority of the time it is something that is desirable, having that higher voltage potential. Cycle life, that's all over the map here. I did put it as a pro because if you do need 1,000 to 2,000 cycles, you might want to go with a lithium iron phosphate, or if you need 6,000 to 20,000 cycles, the lithium titanate cell would be the cell of choice. And this is not an option whatsoever with nickel metal hydride. But your standard, more standard, if there's such a thing, lithium ion cells, they're similar. They're going to be anywhere depending on the temperature of the application, what's the average temperature, what's the average state of charge, but they're going to run somewhere between 3 to 800 cycles, and both chemistries are right in that sweet spot. So, but it is on this pro slide because you do have options with lithium-ion based chemistries to get extreme cycle life when needed. The other area here too is some of the lithium-ion cells can better withstand lower temperatures and also warmer environments compared to some nickel metal hydride cells. And the reason for this is the formulations that I mentioned earlier. You can mix up different chemistries and use different subfamily members within the lithium-ion family to be able to get to a little bit more extreme temperature ranges depending on your application. So you have a little bit more flexibility with a lithium-based cell than you would with a nickel metal hydride cell. And then this one here, the easy charge algorithm. Even when you're powering a load, this was back when that's when I started this back in the early 90s. Kind of dates me, but all we had available back then was before Sony came on the market with their first lithium-ion cell, the old cobalt technology. Was all we had was NiCad and nickel metal hydride, and I'd always cringe when customers would come to us and say, "Hey, we want to charge this battery. At the same time, we want to power our load, and this is what we need." And that's very, very difficult. And I have a slide a little later that'll show you the reason why. But with nickel metal hydride, it's very, very difficult. Lithium ion, it's wonderful because they the cells will charge very, very similarly to lead acid. In other words, you set a voltage and it's voltage regulated. The only difference is it's very tightly voltage regulated with lithium ion for safety reasons, but you current limit. And so as you're charging the cell, you can go ahead and once in a while start pulling current off. You can be parallel with the cell, use power in your product, and then be charging. And so once in a while your battery may not get as much current momentarily, but as your product uses less current, then there's more charge current available to the actual lithium cell. And eventually, when the current drops to what they call taper current, we will terminate charge. But in the meantime, you can take power all you want, and stop taking power, do whatever you want, and the cells will charge just fine with very simple electronics, without much worry about any danger or safety or wearing out the battery or shortened cycle life. It's very, very nice. It made my job much easier once we started using a lot more lithium-ion. The other area here too, a huge benefit with lithium-ion is it has a very, very low self-discharge rate. It's approximately a cell all by itself, sitting on a shelf with no safety circuits and no other electronics attached to it. It's about 1% per month. And if you have an application where, let's say this is down in the bottom of a mine shaft somewhere and it's very difficult to get to, you could have a very low current, low energy monitoring system where you fully charge up this battery pack, and a lot of times you want to maybe over design it and have it higher capacity initially, but you can charge this thing up and you can leave it down there for months, if not years, and because it could be very costly to go back and retrieve it and what have you. But once you do, you can go ahead and recharge it and send it back down the hole again and let it sit there for a few years. And it's an ideal situation where nickel metal hydride can't even come close. It has 30 times the self-discharge rate. So this really, really shines. It almost mimics a primary type cell, but yet it's still rechargeable. So that's a huge selling point, and some applications absolutely require lithium-ion because of that low self-discharge rate. A large selection of chemistries to choose from, as I alluded to, and they're all formulated for either cycle life, high power, like the drill you see at Home Depot, the drill motor, drills that can have a high power delivery, and those are called power cells. Then you have energy cells are designed maybe for not really high current draw, but they're designed to last a long time. They have a lot of energy in the cell. And so all these different cells you can select from in different formulations of the chemistry makes lithium-ion very, very attractive, because you can tailor fit a chemistry or a subset chemistry to your need. And so it's highly desirable a lot of times to go with lithium-ion for those reasons. Same as nickel metal hydride, lithium-ion is environmentally friendly, easy to recycle. There's no dangerous metals like cadmium or lead in any of these two chemistries, and so they're very environmentally friendly. Another thing that a lot of people don't think about is the marketing view. You hear all the buzzwords, lithium-ion. Usually it's big capital letters on the box. When you go walk through the store, they proudly display the word lithium-ion because it's viewed as new, latest and greatest, high tech, and the only reason is nothing is on the market yet to replace it. Whereas nickel metal hydride is not viewed as such, and it's viewed as a much older technology. So going through the cons of, with all good things, there has to be a other side of the coin here. So looking at the kind of negative aspects of lithium-based chemistries, one of the big ones here is the development and regulatory costs. Because it's a little bit more volatile chemistry than nickel metal hydride, we have to wrap around more safety circuits and electronics, and then regulatory will want to test these safety circuits to make sure they truly function as designed. And then also by law, you have to, in order to be able to ship lithium-ion, you have to pass UN 38.3 testing, and that's not optional. That is required. And that can run anywhere from a couple thousand up to over $7,000 just to run that test. And you need 17 samples. And if your product is really big and expensive, 17 samples can run into a little bit of money. And all this takes time, in order to get through the development process. And then a lot of customers will say, hey, well, I don't have to worry about that. I just go to Amazon.com and go buy a lithium-ion battery, and I'm in business, and my product's off running, and I don't have to worry about any of that. But that's true to a certain degree, because what happens is, let's say the average product is you have maybe a lifespan of 5 years. What happens if that battery is discontinued, or what happens if they change the design without telling you, and now it doesn't behave the same. How's that going to impact on your business and your product? So a lot of these batteries really do need to be custom made and custom designed, especially form factors have to fit perfectly with your product. And you have control. If you work with Epic Technologies, you have total control over the design. You own the design, and there's no surprises down the road that you're totally unaware of if you buy something off the shelf. So there's a lot of items there where you really can't avoid these development and regulatory costs if you're very serious about not having changes in your product down the road. And going through here on the cell, one of the big problems with lithium-ion is the cells do have a tendency to lose permanent capacity, and especially when they're kept at elevated charge state and also at elevated temperatures. And probably a decent analogy of this would be you go to the dealership, you buy a brand new car, and let's say it's a very fancy car, so it has a 30-gallon gas tank. So all of a sudden you say, wow, I want to keep this gas tank full with all 30 gallons, and I want to store it down in Arizona on a hot summer day. And so what happens under that scenario is the gas tank physically, it's hard to visualize, it physically drops down to, over time, let's say a 20-gallon gas tank. And you're never going to get that back. Now all of a sudden your nice brand new fancy car you're driving around in has a 20-gallon gas tank, not a 30. And that's what they call non-recoverable. It's non-recoverable, and you lose capacity. And that's what happens with lithium-ion. However, let's say that you say, I'm happy to fill that 30-gallon gas tank with only 15 gallons. So let's say that the battery's at 50% charge, and you keep it at elevated temperature. The rate at which that tank shrinks from 30 to 20 gallons is much slower. So in the exact same amount of time, if you were to keep it fully charged, if you only keep it 50% charged, it shrinks much less. So all of a sudden it becomes a 25-gallon gas tank. It didn't drop it drastically at 20 because you had a 50% charge. Those are the type of things you got to think about. But nonetheless, it's a very negative aspect of the lithium chemistries, and it's something that you need to take into account. And the takeaway there is you need to make sure that you store it at a lower temperature and also a lower state of charge. In fact, I just filed for another patent 2 years ago. I'm getting ready to issue here on just that for lithium-based chemistries and how to prevent that permanent capacity loss. And so that's a pretty cool little part that I've given it a huge amount of consideration over the years on how to avoid that. Another aspect here is that the lithium-ion batteries have active materials that are very similar in a lot of ways to lithium metal batteries. And these ions are very active material, and they can react easily if not controlled through electronics and environment and also mechanical design. And as a result, it can generate a lot of heat, and this is called a thermal runaway. And this is what you've seen in some of the old laptop things that you probably see on YouTube, catching on fire in conference rooms. And then the F7 battery in the Samsung phone. For a while, they actually had some manufacturing defects in their battery, and the enclosure pinched the pouch cell, which caused the battery to internally short out and cause fire. So that is a really a big deal with lithium, and that is one of the downsides. And a lot of people are very aware of it. They're more afraid of lithium-ion than they are nickel metal hydride because they view it as much more volatile. And that's definitely something to consider. As a result of that, it's funny. They're getting ready to load. There's a little side story here. They were getting ready to load CR123 batteries, these are primary lithium batteries. And what happened is they're on the tarmac in the airport, and a forklift went right through the pallet batteries, and it was just sitting there. And then people were watching this pallet, and it was starting to smolder, and eventually it broke out in a huge fire of lithium. And the pilots were looking at it, everybody's looking at it, and that was the birth of regulation with lithium cells, with that pallet catching fire. And it's a good thing it did, because I'm a firm believer in keeping everybody and especially our planes safe. So there's very strict shipping restrictions on lithium, and that is a big factor in if you want to go with lithium-ion, because a lot of times nickel metal hydride is a better choice depending on your product and how you need to move the product around the world. Sometimes that in itself, all those restrictions are a showstopper for your product, so you need to be very aware of that. And also overall, as a result of all this regulation and development time and what have you, as a result, there is a much slower time to market. And if you are a type of product where you need to beat your competition to the marketplace and be the leader, sometimes this could be a showstopper as well. And so nickel metal hydride is kind of fast track and being in the left lane, and you can get to the end much quicker. Sometimes with nickel metal hydride, if the other aspects of it are a good fit as well. And I can't stress enough, it is a more volatile chemistry, especially if misused. We have many, many years experience on how to avoid misuse, and it starts with proper design of safety circuits. It also involves proper design of mechanical enclosure to prevent damage with vibration, because even though you have a great robust enclosure, if the thing rattles to death inside and all the welds break and everything else, you're in trouble. And so it's not just the electronics, but it's also the mechanical structure that's very, very important to keep in mind. So here's what everybody's waiting for here, right? So what's so good? Randy, I talk up a good deal with lithium-ion, because 90% of our business is lithium-ion, at least in my world, because we do a lot of more high-tech products over here with Epic, and then we also with Epic do some of the lower cost products, and some of those do involve nickel metal hydride. And I do, as you know, have extensive background in the 90s, and even recently we've done a couple projects with them for these good reasons here. Overall, there's lower development costs, because since it's not a volatile chemistry, we don't have to have as many safeties in place. There's still safeties, which we'll go over here shortly. And regulatory costs are next to nothing, and usually you don't have to worry about regulatory unless your end product requires it, like your end customer or your distribution chain requires it. For instance, if you want to sell through Home Depot, they require anything with electricity has a UL mark of sorts. That's some sort of regulatory mark. Doesn't matter what it is, and it's just to be able to sell it. So sometimes those are driving factors, but a lot of customers, they never submit their products whatsoever to regulatory, and that's perfectly legal. There's no problem there. Then also, what's really nice, unlike lithium-ion with that non-recoverable capacity loss, it can be left at 100% state of charge with no cell degradation. And it's so in some areas in the old server markets for IT, what have you, that was a cell of choice many years ago. And nowadays there's some really good formulations of lithium-ion that work very well at 100% state of charge, with very low reverse capacity loss. So I know even the lithium-ion cells are catching up, but it is a really huge benefit to be able to keep this, especially if you need your product full power instantaneously all the time. It's a huge benefit to go with nickel metal hydride. As a result of a lot less development, no circuit boards, what have you, you have much faster time to market, a big plus there. And also, nickel metal hydride cells are safer because they are much less volatile, and they have a lot less active ingredients compared to lithium-ion. But also, as a result, they have a little bit lower energy density. That they usually go hand in hand, and so that is a downside there. Also, nickel metal hydrides can be completely discharged. Unlike a lithium-ion battery, which we have safety circuits that cut out minimum voltage, because that can be a safety issue and also a cycle life issue, nickel metal hydrides can be completely discharged. Where it's safe is if they have a 1% discharge per day. If they naturally discharge on their own without, let's say, a load, they're just sitting on a shelf for 2-3 years, and they discharge, that's pretty safe. They can be down to 0 volts, and you can bring them back, no problem. The trick there was they were not forced into a discharge. And when you force it, let's say you have 10 cells in the pack and they're all series, and you force a discharge, all cells are slightly different. It's kind of like a fingerprint. You know, you can never duplicate a cell in manufacturing. They can be very close, but they're never the same. So if you force it down to 0 volt during a discharge process, especially a high current one, some cells are going to have a slight voltage while the other ones are lower, and that could force it into a cell reversal. That's really something you want to avoid. So if you have a product and you're discharging, you do want to think about shutting off your product just before the cells are fully discharged, just to prolong the safety and also the viability of the battery long term. So, but it is something that is a nice little feature with nickel metal hydride. Also, a big deal is customers. You think, okay, great, I got this lithium-ion battery, I can send it out. I put all the regulatory labels on the box, and everybody's at the factory's trained to do that. What happens with a customer? You have an expensive battery, and a customer says, "I have a problem here with either battery or something like product, and the battery's in your product, and they need to return it." And how do they return it legally? And it has lithium battery in it. How do they know how to mark the boxes? How do they know how to ship it? That's a big problem. A lot of these products are not one-way streets. Some of them come back, and so it adds a level of complexity with your shipping department and logistics with your customer service department. How do you get these products back? Nickel metal hydride, all that's avoided. There's no problem. Just throw the box and put it back. And that's a huge plus. It saves a lot of overhead costs. Also, the nickel metal hydride comes in a lot of common sizes. It's very similar to alkaline cells, and those can sometimes be replaceable because recall they're at 1.2 volts, very similar to an alkaline cell, and so a lot of times you can pop out these alkaline cells, charge up your nickel metal hydride batteries, pop them in the same form factor in your product if you have a really low cost product, and now your product has a rechargeable option. And that this is very common. It's been around even since NiCad days, but it is something that you really can't do with easily, I should say, with lithium-ion batteries. So that sometimes with lower cost products, that's a real selling point and could drive your usage to nickel metal hydride. And as with lithium-ion, if they are environmentally friendly, there doesn't have any cadmium or lead in the product, so easy to recycle, and it's good for the earth. Probably one of the larger benefits to nickel metal hydride are very large batteries can ship air without regulation, and that's a very big selling point sometimes, compared to lithium ion. Okay, on the downside of using nickel metal hydride batteries, as I've probably said 2-3 times so far today, you've got 1% per day, not per month, but per day capacity loss. That's like 30% per month. That's huge. So you can rule out any low current applications. You can't put this down in a mine hole for a year. It's totally discharged in a short amount of time. So sometimes that's a showstopper in going with the nickel metal hydride battery. The cells are heavier, and you'll see in a slide coming up, it's about 50% heavier for the same amount of energy, and so it's much less portable, and it's something definitely to consider if you're striving for a very lightweight product. Maybe nickel metal hydride is not the cell of choice. And I mentioned earlier about the low cell voltage. More cells are needed, more welds, more things to go wrong potentially. That's definitely a downside of this chemistry. And then what I had mentioned earlier, what I really love about lithium-ion is the charge algorithm. The charge algorithm is very difficult compared to lithium-ion. And over here, off to the side here, I've got a quick little graph. And if you look at the green up high, there's what they call minus delta V. And you hit this at C is capacity of the cell. So if you have a 1 amp hour capacity, if you hit it with 1 amp, that's a 1 C charge rate. And if the higher the charge rate is, the more pronounced that what they call minus delta V, because it's going in a negative direction, more pronounced that is. And that's what tells you when to terminate charge if you're using a fast charger. If you're going like a C over 10, which is considered a slow charger, if you notice, there's really no minus delta V. Very, very difficult to pick up the charge. And those chargers are normally time-based, where they'll just bake them for a while and turn off, and now you look at voltage. But more the higher tech products that you want to apply these nickel metal hydride batteries to, all of a sudden, let's say you do want to run your product, like those customers asked me back in the 90s, hey, I want to run my product, and I want to charge the battery at the same time. Great, just make it happen. Well, easier said than done, because this whole graph here is based on a constant current, and I doubt there's many products out there that draw a constant current. If you did, it'd be no problem. We just say, okay, dedicate so much current for the charging of the battery, and you can have the other leftover constant current. Life is great. We can see the minus delta V. We know when to terminate. Battery doesn't overheat, and everybody's happy. That's never the case, ever. It's you got batteries with motor loads. You got batteries with the transmitters, the cell phones, whatever. They transmit for a few minutes, draw a lot of power, a lot of energy, and then they stop for a while. And then this minus delta V is all over the map. You can't even detect it. So a lot of things we used to do, and you can still do it. It's not only is there a minus delta V at the end of the charge, but temperature goes up. It will exponentially go up. So we do what they call a delta T, or a delta I over delta time, where you look at the amount of temperature. So actually it's a delta T over delta T, small t over big T. And so as it increases, you can see how many degrees C per minute it increases. That's another way of terminating. And you can get around, you can still run your loads, what have you, because that's not affecting the temperature rise a whole lot. And it also has a thermal gradient lag at times, so you can pick it up easier. And also some of the really high-tech batteries, like they use in buses, the old, and now it's more lithium-ion, but they would actually have pressure gauges built into the edge of the cell. And so, because the other parameter that goes up in the charge on nickel metal hydride is the internal pressure will build up. And that's a really good way of determining when the end of charge is. But that's for these batteries are thousands of dollars each, and it's definitely out of the scope of what most of you are probably working on your project. So, but those are different things. Charging is a challenge with nickel-based chemistries. NiCad was the same way. Lithium-ion does make your life much easier in that area. And also, going up here on the upper right here, nickel metal hydride has a slight disadvantage at extreme temperatures. This is probably more downplayed now. I put it as almost like a sub-bullet. It's less of an issue. Other chemistries have the same problem, like lithium iron phosphate also has struggled historically at low temperature. But it is something that it's not a strong point whatsoever with nickel metal hydride, so it's definitely something to keep in mind. Another thing too, another more of a sub-bullet is during the end of charge, nickel metal hydride is an exothermic nature cell, which generates heat more so than a lithium-ion battery does at the end of charge. And it's definitely something to keep in mind if your product is very thermally sensitive. Some medical products are, what have you. The cells are still good. You can touch them; they're not that high, but it's definitely notable. And if your product can't handle heat, maybe the battery needs to be external to the product. Things to think about when applying this chemistry. And then also the battery charger needs to have a trickle charge, and it's a little lower than the NiCad days. You're looking at whatever the capacity of the cell is divided by 30. And that needs to be a constant trickle, where unlike lithium-ion, you cannot trickle charge lithium-ion. That's a really, really bad thing to do. But here, that's required in order to keep your battery fully charged. And that's mainly because of the high daily loss of energy through self-discharge. And again, same with lithium-ion battery has high-tech. Nickel metal hydrides are considered low-tech. And your marketing department can easily get around this by pointing out the reasons why you decided to go with nickel metal hydride. It could be shipping, no regulation, no returns are easy. You could be highlighting all these other things on your box versus nickel metal hydride. And so it could be actually, you could turn it into a positive by pointing out the weaknesses of lithium-ion and why you decided not to go with lithium-ion. So factors, to consider when choosing the nickel metal hydride batteries. Kind of touched on this. I believe in reiterating a lot of stuff because that's the only way it really sinks in. But here, we've got weight, energy density, we've got design simplicity, time to market, regulatory costs. We're digging a little deeper here. And if you look at weight and energy density, on the periodic chart, I just threw it in because pretty colors, I guess. But you got number 3, on the periodic table. Lithium, the smaller periodic number, the lighter weight it is. So compared to nickel, it's up there at 28. It's a very heavy metal compared to lithium, and also you've got other metals in nickel metal hydride batteries, and you've got carbon in the lithium ion batteries. So overall, the lithium ion is lighter. And you look down at this other chart here, and you can actually, it's very eye-opening, where if you look at the vertical axis here, the green here is essentially nickel metal hydride. The big oval is more the cylindrical cells, and the small ones are prismatic. And same with the red up here is in the cylindrical lithium ion and prismatic lithium ion. And prismatics are what essentially are in your cell phones. And if you look at this vertical axis, this is the amount of energy, how much energy is in there by weight, by pound, kilogram. And so just taking a step back and looking at this, if you look at the nickel metal hydride and versus lithium ion, round numbers is 50% heavier. Now, so you've got, for the same watt hours, you got more weight. And then if you look at the horizontal axis, this is what's kind of eye-opening between two chemistries. People think nickel metal hydride is a weaker cell. Well, in reality, it isn't much, because the horizontal axis is energy by volume. So if you look at these, they're very, very similar. Sure, nickel metal hydride is a little lower, but it's right up there with lithium ion if you look at the horizontal axis. So kind of the takeaway here is, let's say that you had a cell phone and you ignore the prismatic and all that nature of it. Let's keep it simple here. But if you had a cell phone and you had identical cells that could fit in your cell phone, the exact same size, what you would notice is your talk time would be very, very similar. So you say, oh, they aren't weaker in that sense. You can, for the same volume of chemistry, you can have almost the same amount of talk time. It's going to be a little less, but not much. But one thing you will notice is the battery is going to be roughly 50% heavier. And that's something that is very noticeable in the phone. So, something to keep in mind, if you can get away with a little extra weight in your product, and some products, it's actually a nice side effect to have, then, which we'll cover here shortly, but, then it's something to definitely consider. Nickel metal hydride is a very viable alternative to lithium ion. Another thing that I mentioned earlier is design simplicity. Here's a slide. I threw in a PTC. This little brown, little 2-liter device is really the only safety you need. We sometimes throw in temperature devices as well, depending on the application. But the main thing here is that's a resettable fuse. And what it does, it essentially protects you. If you short out the outputs on this connector and wire, there's a lot of energy in these nickel metal hydride batteries. And one thing you don't want to happen is for the wires to catch fire or burn or whatever. So we want to make sure that that they're protected here. And so, just reading up a couple of notices just popped up here. Hopefully you can still hear me. And so this little PTC here will protect the wires and the shrink wrap and everything else. And the temperature, sometimes you put a clip-on in there or something to prevent any over temperatures as well. The time to market, because of all the simplicity and the lack of regulatory, engineering can be done in the afternoon. It's just pull out our boilerplate designs and stack them and weld them and put in our safeties, and you dictate what the connector is or no connector, 10 leads, and we're done. That's it. And we can ship you the battery for you to test. And we don't need any special shipping. Just throw it in the box, send it to you, take off the leads that's required by law. But it's really easy, and we can get you to market extremely fast. And speaking of regulatory, this is about all there is on regulatory for the for the nickel metal hydride products. The UN 3496 was actually originally developed for overseas transport for big ships and what have you. They put the special provision A199 that's more for air transport. And the only thing is you have to protect your exposed terminals, and you have to put the words not restricted in your packing list, and A199 must be included. That's what's needed for air shipment. And so it's really straightforward, really easy, no external markings, what have you. So it's pretty nice and really straightforward compared to lithium-ion. And here we'll just go over a couple of examples here, some ideal applications, just so you can wrap your head around some of the things I'm trying to convey here. Nickel metal hydride batteries larger than 100 watt-hours can be easily shipped by air. That's a limitation with 100 watt-hours. In the 100 watt-hour battery is not much. You think about it, it's about the size like a DeWalt, drill battery that you buy at Home Depot. It's not a very big battery. So if you have an application where you need a lot more power than that, we'll fudge it a little bit. Sometimes by law, we're allowed to put 2 independent batteries in one enclosure. So we can squeeze out 200 watt-hours and still ship it legally, and saying it's 2 batteries that are independent. And when you plug in your product, it looks, feels, and tastes like one battery because it connects them together and turns it into a 200 watt-hour battery. But you may need more than that. And a lot of applications need 300 or even a kilowatt worth of battery. You can get around that. We have a medical customer where we have 500 watt batteries that we put in their system, and there's a lot of electronics in there, so balancing them all out before they connect to the rail, and you can avoid all those hassles and all that expense and time to market if you go with the nickel metal hydride. And so it's definitely shines, and sometimes it's the only solution you have if you have very large batteries that need to ship air, and because of time, you don't have time to ship these batteries by boat and what have you, and go through the hassles of that. So some of this is a good example that would be let's say large movie, remote movie film set camera batteries. A lot of movies need to be very, very quiet, so generators are not an option. Let's say they're in the middle of Africa, there's no power available, but yet these batteries get shipped all around to different film sets. You can have very, very large batteries, and you can ship them around by air, get them there overnight without any problem and no hassles, and totally legal. And so it would make total sense to go with nickel metal hydride in that type of scenario. Lithium-ion is totally out of the question. It's not even an option whatsoever. Also, scientific suitcase batteries, a lot of scientific equipment, remote labs, they all need to be in nickel metal hydride. You can't use lithium-ion in those scenarios, and they have to be very large because of long run times. That's definitely it. Same story with emergency UPS batteries for very large backup systems. Very important, to be able to use nickel metal hydride, since they can be moved around quickly and easily without the interference of regulatory or shipping restrictions. So you get the general theme here, some of the larger batteries. And coming down here, one thing I've ran into just through all my years experience switching over from medical cart batteries, a lot of them were lead acid, 24-volt lead acid batteries, and then nickel metal hydride came around, switched over to that, and then the hospitals want the latest and greatest lithium-ion, put lithium-ion in there, and then all of a sudden they're saying, wow, these medical carts work great when you're rolling around corners because you have less inertia going around the corner, but all of a sudden they tip over and you don't have ballast. And so you have to think about it. Sometimes weight is a good thing in your product. Sometimes it's necessary. And I put the second bullet down here, and down here it's like with the Surface laptop computer, one of them I have in my lab. I wanted the more laptop feature where I can have it on my lap. But the engineers were pretty intelligent. They decided to go ahead and use a nickel metal hydride battery, and because they got a bunch of benefits. They got regulatory. They can avoid the regulatory issues. They can go through and have the ballast they need, so that the top heavy Surface and the tablet doesn't tip over, and now they have weight for the keyboard. and it was less expensive, and they made more profit as a result. So I thought it was a very intelligent decision what they did, and by going with the nickel metal hydride battery. So the takeaway here is anything, if weight is needed to stabilize your product, get very serious about nickel metal hydride, because you get a free benefit, and it's a lower cost solution, and you can increase your profits that way. The last topic that I'd like to cover is people think, okay, low technology, nickel metal hydride, it's old. Well, you can make it smart. Because a lot of people associate lithium-ion batteries as smart batteries. They tell you everything. You can control them, what have you. There's no difference. You can put the same amount of intelligence in a nickel metal hydride battery, and be able to communicate with it, and also have it communicate to the outside world. And what makes a smart battery smart is the fact it can give you runtime and charge levels, battery voltages, anything of interest to you, historic data, you name it, it's available. Sometimes battery temperature is important, maybe during charge, you want to keep things under control. State of health, every time you charge and discharge this battery, it keeps track of what the original design capacity is, and it monitors what the most recent measured capacity is, and you can see how the battery's aging over the life, and you can predict when the end of service will happen. Runtime, very important, number of bars on your little battery display on your product. Remaining charge time, when you can take the battery off the charger and run. All this is available. We can make these nickel metal hydrides very smart batteries, even though it's older chemistry. We can make it equally as smart as any lithium-ion product on the market. And how we communicate with the outside world, the most common ways, and actually I should put another bullet up here, LEDs is another one, but through I2C, the simple, very common protocol in SM-Bus, which is nothing more than a subset of I2C, very common in the battery world. It uses a little less power, that's why it's very popular. And also, if you don't have enough contacts on your existing connector, especially if you need to make it backwards compatible with existing products, and you only have one pin available, then single wire communication is an option. It's much slower, but it's an option. And another thing people really don't think about smart batteries that makes them smart, but yet you don't really realize it. Like, you look at this battery here, there's two wires. Well, it doesn't communicate because it can't, because it has only power wires and no communication wires. But there's a lot of things we can do to make a battery smart. And one of them is a built-in charger. There's some times when you've seen it all the time, you got a whole drawer full of wall bricks, and it's like, well, which one came with my product? Unless you put a little sticker on it, you don't know. And so you always take the risk that someone's going to abuse your battery by plugging in the wrong wall brick, and that can be a big problem. And so this here with a built-in charger, you can put in some pretty sloppy input power. It'll clean it up, make it nice, massage it, and make it just perfect. And your battery will maximize life because it's getting the exact charge algorithm you designed it to have. So it's pretty nice having built-in chargers. The downside of that, of course, is when the battery wears out, you're throwing away a perfectly good charger, and that can get costly. So those are only certain situations where that really, really makes sense to go that route. A lot of times customers will request, hey, we don't have enough room on our product. Can you throw some of our electronics on the battery? Kind of afterthoughts, maybe lack of planning, who knows what. But many times we put customer electronics on the battery. Some of this is for to prevent counterfeit batteries as well. So that way, someone doesn't use an off-market battery that is not approved with the product, and you don't want damage to your product. We can put that electronics in, so there's a guarantee only your battery is used with your product, and there's some benefits to that, and so it's worthwhile entertaining sometimes. Built-in fans, we've done that where we have plastic enclosures. We cool out of the battery, plus we cool the product. There's a lot of things that we can do there. We put thermostat regulators in, you name it, we've done it, and we're pretty good at it. Also, integrated heaters. This really comes in handy when you have an application where the battery is going to be used in a cold environment a good portion of its life, and we can bring the battery ambient temperature above the outside ambient, and therefore you can advertise your battery runs at a colder temperature than your competition. Yet you're kind of cheating because you're using some of that unavailable energy it's kind of like bootstrapping, pulling your boots on by its straps, where you're using some energy that's barely available, and by using it, you're unleashing more energy because you're bringing the battery temperature up. It's a cool concept, and it works quite well, and we have a number of products with integrated heaters, and that does make a battery very smart, and but on the outside surface, it looks, quite dumb. And so, in summary, that was a mouthful. I apologize for that, but a lot to say here. In summary, we went through the pros and cons of each chemistry. The really good news here is each chemistry, between the two, and that includes the entire family of lithium-ion. You got some major differences there, which usually makes the choice easy. And when you factor in all the items here, the weight, energy density, design simplicity or complexity, depends on how you look at it, time to market, regulatory costs, you'll have a really good idea where you need to lean in your product. It's not like where the lines are too blurred between the two chemistries. There's a really decent separation between the two. And a lot of times it'll make the choice quite easy and quite apparent when you start looking at all the factors in a complete form. And then you've got stationary large batteries. Obviously, that was the takeaway there, where obviously where this really shines and lithium-ion has no competition whatsoever are large batteries that need to be moved around the world in a very fast manner, and the only way is to air transport them. And lithium-ion cannot do that at a cost-effective way, because you're going to have special charter cargo planes to do that, and it's very, very expensive, and you have a lot of overhead in your office to make that all come together logistically. And I don't care how good you're at it, things are going to get hung up in customs, paperwork won't be perfect, and you'll miss deadlines and getting your product to wherever it needs to be in a timely manner. So you can avoid all that with nickel metal hydride large batteries, and that's a very important takeaway. And also, nickel metal hydrides, as I discussed, is they really can be smart, and they can look, feel, and taste like a lithium-ion without any problem there. And we can make it turn it into anything that you need for your product, especially if you have any unique requirements. Epic is very, very good at taking in your input and coming up with a very, very good solution, regardless of the chemistry. So I'd like to hand it back over to Hydride to go over some of the products that Epic provides a full turnkey, and there's a whole lot more than batteries that what Epic does.
Thanks, Randy. And Randy's going to go over your questions that came in. Keep them coming. He's going to take a minute just to review them, and then he's going to answer a few. And then the balance of them will go ahead and get out to everybody onto our website and individually. Just briefly, mention some of the additional products that we make. I mean, as many of you know, Epic has been in business for over 65 years, manufacturing all types of electronics. Not only do we manufacture at our plants here in the U.S., but we've got locations in the U.K. And in Asia. So not only in China, but in Malaysia and Taiwan and in Thailand. So all of these products are made globally. Most of them are designed here in the U.S. with people like Randy and our other product experts. But looking at what we do as a company, it's more than just a product. As you saw with what Randy talked about today, we really offer that design service for all of these things as well. And that's, if you look, many of them, we put more than one into every product. So there's a lot of opportunity here. We hope to be able to work with our customers. And with that, I'll kind of go back to Randy for some of the questions.
Thank you. Yeah, and here's our Q&A. I was going over a couple of them as Ed was describing what Epic does. And a few good ones here. Actually, I need to increase my bullets and maybe increase my talk by another 15 minutes here, because I should not be missing these. These are good ones. One question here is, it says, I noticed in the section about how nickel metal hydride batteries can be smart batteries. Does this mean I need a BMS in my nickel metal hydride battery? I just saw a lot of electronics on your slide. That's actually a very good question. And a BMS, for those that don't know what that means, that's a battery management system. And a lot of times that's grouped into any electronics in the battery. It could be safety circuits, it could be fuel gauging, that sort of thing. And that's what the BMS is. It's electronic circuits to help control your battery. And the answer is no, you don't need it. And a lot of it, you can just have, just the fuel gauging portion. You don't need to have the safety portion in there. So it can be very, very simplified in nature. So you can strip all of that. So definitely you do not need it in there, but we would want, if you want fuel gauging and know the capacity and runtime in your battery, we can just put only the fuel gauge portion in. So that's a very, very good question there. Another one that came through, I can cherry pick these, but I know the answers here. I heard, this is the question here, I heard nickel metal hydride still needs to be shipped a full class 9 hazmat sometimes. Is this true? And that's where when I was looking at that, that's why I kind of chose this one, the answer here, because I think a lot of people can benefit from the answer here. And that is absolutely true. If you exceed 100 kilograms, which is over 220 pounds worth of battery, think about that for a second. That's a lot of battery. If you exceed that, you do have to go full hazmat, full class 9. You can't get around that. But for our talk here, it's rare that we ever see batteries that size, or we're shipping them all together at 220 pounds worth. So, but a very good question. And yes, it is absolutely true that you do have to go class 9 if you exceed 100 kilograms in batteries. So the very, very good question there. Let's see, another one here. This one here, it says, can nickel metal hydride batteries catch fire like lithium-ion? I have to laugh at that one because it's true. The office next to mine caught fire, sprinklers went on, fire department came out and had to evacuate the building. Yeah, it was a substantial amount of damage. What happened there is one of the engineers left the batteries charging overnight, and it wasn't me. Engineers anyway, but yeah, I left it there charging overnight, and they had the settings on the charger. It was a large whole bank of batteries, and they had the charger setting incorrect for the wrong voltage, so they kept pumping energy in, ignored the minus delta V, and the batteries did catch fire. The shrink wrap just melted, and gases came out. They vented. They did catch fire, and the whole area caught fire, and the office did too. So that was you do have to be careful. Even you can even lead acid batteries can catch fire if you use them enough. So you really need to be cautious on how you handle these. They are much less volatile in nature. They're not like blowtorch when they go off, but they definitely can catch fire. And so this is definitely something to consider and be aware of, especially with your environment when you're testing these. Make sure there's no flammable materials in your lab. Let me see here, another one. Just going through these. Yeah, this one's actually pretty good. Yeah, I heard adding a safety circuit similar to lithium-ion is good for nickel metal hydride batteries. If so, why is that? Yeah, actually, we've done that. It's interesting because even though you can go down to 0% charge on a nickel metal hydride battery, as you remember, I mentioned if they just naturally go down to that 0% charge because they're sitting on a shelf and you don't have a load on them, that's fine. There's going to be no harm whatsoever to that battery. You do want to bring them up slowly regardless in charge. You don't want to hit them at full charge. You want to nurse them back a little bit to a minimum voltage before you hit them with a little faster charge. But with a safety circuit, which we've done, we don't really monitor the individual cells like lithium-ion. We will actually look at the overall pack voltage because you really don't need to get down to that level of detail and add all the unnecessary costs. But we have put in circuits where, let's say we have a really heavy load and we're just driving the heck out of this battery and it's getting close to a minimum voltage of the cell. In order to avoid that cell reversal that I talked about earlier, we do put safety circuits in to disconnect the battery when we hit minimum voltage. That way, none of the cells ever can get into reverse polarity, which is extremely important with any chemistry, not just nickel metal hydride. And so where that really comes in handy is when you do have high currents and really heavy loads, and you're driving these batteries hard, it's very good to have. It's a nice level of safety to prolong safety life, product life. Your battery will last much longer by doing that. It's very rare that we do this because most applications have very light loads, and it's kind of worthless why add the cost if you have a light load. But definitely worthwhile considering under certain applications.